Welcome to Emilak Online tutorial. Now let us consider this question in the limit of a function. Alright, we're given that the limit of sine 6x plus sine 2x all over sine 5x minus sine 3x as x tends to 0. Alright, let us recall one of the trigonometric function or rule that says sine A plus sine B. Now this will give us 2 sine A plus B all over 2 then cos A minus B all over 2. And in the case of sine A minus sine B, now this should give us 2 cos A plus B all over 2 then sine A minus B all over 2. Alright, we'll be using this rule to solve the above function. Alright, let us now apply this. Now for the first one here, I'm using this rule. Now this will also be where where for the numerator here A equals to 6x and B equals 2x, and for the new denominator A equals 5x and B equals 3x. Okay, now applying this rule here, we have 2 sine 6x plus 2x, which is 8. Let me just put it that way. So this is 8x all over 2 then cos, in this case 6 minus 2 will give us 4x all over 2. Now this will give us 2 sine 4x cos 2x, right? And now we've established that one. Now for the new denominator here, you have 2 cos, now 5 plus 3 will give us 8. 8 divided by 2, let me just put it that way so that you get to flow together. Then sine 5 minus 3 will give us what? 2x all over 2. And this will give us 2 cos 4x sine x. Wow, alright. So here we have limit of, here you have 2 sine 4x cos 2x all over 2 cos 4x sine x as x tends to what? 0. Now at this point we can eliminate this, so we are left with x tends to 0 sine 4x cos 2x all over cos 4x sine x. Alright, now let us also recall, according to a theorem in the limit, I see that sine x all over x as x tends to 0 equals what? 1. Okay, alright, now let us look at this function and see how we can resolve this to give us for us to resolve this, to have each of them to be in this form. Okay, so now let us also recall that tan x equals to what? Sin x all over cos x. Okay, now this function here can also be rewritten as sin 4x all over cos 4x, right, times 1 over sin x times cos 2x. And let us also recall that the limit of cos theta as theta tends to 0 equals 1. Okay, all right. Now just trying to see how we can work things out here. Now at this point here, we can establish that if we represent this as 4x, represent this as 4x, definitely this one will be what, 4x. So we can say here you have a tan 4x. Okay, so at this point here, you can say this is tan 4x times 1 over sin x times cos 2x. Now at this point, our 2x can be theta. Okay, now how do we now establish this function here from this? Okay, now since here we have 4x, okay, all right, okay, so we can say here, let us multiply both sides by 4x, and by 4x we can say this is 4x times tan 4x now divided by 4x. Now take note that this 4x, we eliminate this for the 4x to give us tan 4x again, then times 1 all over sin x times cos 2x. Okay, all right. Now this 4x can also be splitted, so our x here can still move anywhere here, right? So here we have, take note, we still have the limit. Sorry that I didn't include it. Okay, so here we have 4 times tan 4x all over 4x. Now this x here comes over here, sin x, then times 2x, right? So sorry, actually I'm actually meant to implement this here. Okay, this one also should be, limit as x tends to 0. Same thing here, limit as x tends to what, 0. Okay, so at this point, let me be sure. Okay, from here, at this point here, so this will now be 4 limit of tan 4x all over x as x tends to 0 times limit of x all over sin x tends to 0 times limit of cos 2x as x tends to 0. So this will now be 4. This, now the whole of this function here is 1 based on this rule. The whole of this function here is what, also 1, and the whole of this one is also what, 1. So here we have 4 times 1 times 1 times 1 equals what, 4. Okay, all right, that's the final answer. And if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and chemistry. Thank you and God bless you.